So, I think we are ready to start. So, hello everyone, my name is Santiago Velasco. I am the team leader of safeTbox, and I am here today to present to you this webinar about model-based safety engineering with safeTbox. All right, so let's start with it. All right. I would like to start introducing shortly the Institute and our department. So as you see, we are the Fraunhofer IESE, which stands for Institute for Experimental Software and Systems Engineering. We exist since around 2000 years, sorry, 20 years already, and we are sitting in Kaiserslautern. And yeah, well, as you see from these days, also from home, from around the Pfalz. So as you see, more than 200 employees contribute to research and industry projects around Germany and across Europe. And yeah, on the right side, then you can see the fields of application our employees are working around. And yeah, well, you can imagine we explore every aspect of the software, namely the processes, requirements engineering, big data, artificial intelligence, and many other fields. Yeah. So yeah, now when you look a little bit closer within the Fraunhofer IESE, you will find us within the in the department embedded systems quality assurance, right? And we are basically focused primarily on safety competences. So yeah, we provide services in this regard with respect to safety lifecycle activities, meaning we support companies in this area, but we of course developed and adapt methodologies and tools, of course, for the concrete needs of our customers. Good. Here you also see a couple of the current development and research activities that, yeah, luckily we're not going to talk about them today, but if they sound interesting to you, you might visit our website and get to know a little bit more about them. So today we will focus on our tooling aspect and the mold-based solution that we have called safeTbox. All right. So yeah, the topics that we want to cover today are basically two things. One thing is I would like to give you a very short introduction to how do we see mold-based and as a solution for the traditional way of doing safety with tools. And afterwards, then we would like to talk about the safeTbox tool. Namely, we would like to see how this safety life cycle can be supported with safeTbox. All right. So yeah, talking about a bit of the safety life cycle, here we see an abstract representation of the V-mold with the main activities from the design point of view, and on the bottom we see some of the most important activities from the safety life cycle. Not all of them, but let's say the ones that at least our system support. So if you come from the safety domain, then you know that this is not really a straight line as pictured here, but it's more like a spiral of refinement in which designers and safety engineers continuously interact, right? They exchange models, they take decisions, and these, through this iterative process, refine and shape the final product. So what challenges do we see here in this interaction? Well, basically, one of the first things that I just mentioned is about this communication aspect. So the stakeholders, as you know them, they need easy means to communicate. If they are not able to communicate, then this will make the process go slower, and let's say bugs in the system will be included, and this difficulties in the end the process. So making the information exchange being focused to the specific needs of the stakeholders is very important to make that communication and the design efficient, right? On the other hand, we have like different phases, different tools. This means, of course, you will use or you will typically see different tools used in different phases of the design. And for each of these tools, basically, you have a high learning curve, meaning, yeah, every tool is different. You will have to learn how to use them. You need to learn the user interface, the commands, the menus, etc. So it takes you quite some time, or let's say to your engineers to get used to it, and yeah, you have to live with that right now, right? And one of the other important things about having different tools is this interoperability aspect. So basically, since you are having a tool chain, you need to, let's say, take the output of one system or one tool and put it as input into another tool. And what typically happens here is that a lot of information might not be compatible, or if you are able to move around information, then some information might get discarded simply because it cannot be imported or is not supported by the other tools, right? Another aspect with respect to interoperability is extensibility of the tools. Many of the tools in the market are not really easy to extend, or they are not extensible at all. And there, of course, you have a problem, because if you want to adapt your tool chain, or you want to, let's say, chain those tools, then you have the problem that you may not be able to, right? And another important point is about this information inconsistencies and traceability, meaning that even if you are able to shift information, or let's say to move information from one tool to another, then you still have the problem that that once you want to maintain that information, whenever you update your information in one tool, then well, you basically have to do the same in the other tools, and this requires certain process to do it, and to make sure that the information is not lost and that the updates are done correctly, and so on and so on. So this makes things all a little bit hard to in our current daily life, right? So, and this is basically what we see that's happening in traditional safety engineering. So typically you will see that for the HARA we will use Excel, for example, that for the safety concept, the safety case, or for item definitions, then you will basically use Word, because this typically includes a lot of explanations, maybe figures and so on. And yeah, for requirements engineering, then you have more specialized tools. And yeah, whenever you go for, let's say, validation, verification, simulation, and design, then you will have even more specific tools to work with, right? Yeah. So the point is that now, what can we do about it, right? So, well, our answer to that is to move towards integrated model-based safety engineering. This means that we want to formalize to a certain extent those documents that we're seeing, right? That we use as we usually, let's say, make use of them in these other tools. And yeah, the idea is to integrate those in a domain ontology. And this is kind of like the picture that you see on top right. So these are all the concepts that bring many of these artifacts together, and they are integrated, and then they will be able to be displayed through views. And so this is basically what we want to achieve here. So we want to make sure that all these artifacts and all this information that is documented in those different tools somehow relate to the same model, and this model contains these artifacts that are connected to each other, so that we have a gain from that. And what is the most important thing about it is the traceability aspect, right? So once you have those artifacts connected, right, and then you're able to trace them, yeah, well you can gain a lot from it. to analysis, with respect to traceability, with respect to some checks like for consistency or completeness, so checks and so general validation checks with respect to your models, right? So yeah, so this is maybe one of the important aspects that you should aim at when having such an integrated model, right? And yeah, so basically, um, how can then yeah, how can we support that? Yeah, well, we want to therefore present to you today safeTbox. safeTbox as a tool that implements such an approach. And yeah, what is safeTbox? Well, safeTbox is an enterprise architect add-in. This means that you can extend and specialize the UML by doing profiling, right? Which basically allows you to define your domain-specific mode. So this is what I presented already. And moreover, it gives you the possibility to also extend the functionality by executing your own C# code. And this is basically also what safeTbox is. Well, safeTbox is a little bit more than that, but let's say this is the core extension possibilities provided by Enterprise Architect, right? Good. And what else is safeTbox? safeTbox is, we just not only wanted to have, of course, an integrated solution, but we're also looking at the other aspects of a model-based solution that are very important, which are the usability concept. So basically, we just not only want to have a model or be able to model, but we want to be efficient doing that modeling, right? And we want to, let's say, get fast over our activities because we want to focus on the things that we do and not waste time just in some modeling some dumb aspects, you know. Good. Yeah. So yeah, as you see here, we'll see that soon. Basically, safeTbox provides its own set of context menus and controls and shortcuts and so on, and we will see that in action relatively soon. All right. So yeah, as we saw already in the introduction slide, so we'll basically have some techniques that we already support and that we consider maybe some of the most relevant techniques within the safety analysis, or let's say the safety life cycle in total. So I would like to start presenting the hazard and risk assessment and how do we support it with safeTbox. Okay, so as you see here, the HARA that we support is a predefined template for the automotive domain, according to the 260.262. Basically, this is kind of fixed in the sense that the template is already there. Nevertheless, this can be through these extensions possibilities from EA can be easily adapted to any old domain. In fact, the only thing that I would say is specific to this to the automotive domain is the use of the IESE levels, right? But in theory, the rest of the concepts that we use in OHARA are relatively easily to adapt and use by other domains. Okay, so and we'll see how a functional hazard analysis is performed in safeTbox. And one of the other things, of course, that you can do is to define a catalog for hazard guide words, meaning these typical words like omission, commission, too early, too late, and you will be able to define your own. And we will have also the possibility to create such catalogs for situations, meaning driving and standing situations, which is a concept that we have integrated in the tool to just separate these two scenarios, which I'd say from the automotive perspective maybe are some of the most relevant way of distinguishing the all possible scenarios in the that you want to use for doing your risk assessment. And yeah, of course, finally, the risk assessment is then performed according to the ISO 262. So, all right. let's take a look on how that actually is supported by safeTbox and what we can gain from it. All right, so switch now to my model, and yeah, so here we have already open our Hara, and basically you see on the bottom several tabs, and this describes these steps that are meaningful to be performed within the Hara, and yeah, that allows you to create such an important document. So we have, of course, something very basic like your cover sheet, your history, a couple of guidelines on how to perform this HARA. This, of course, is flexible, and the user will be able to exchange those descriptions and adapt it, or let's say tailor it to how the company works. And but in the end, I would say the rest of these tabs of this Hara sheet are basically more or less fixed to from the functionality point of view. All right. So what can we see here? So basically, our Hara works in the following manner. So in this first tab, call functions, then you will be able to load existing components or existing functions. And then you will see here a list of components, let's say functions. Depends on how what abstraction level do you use for your Hara, and you will be able to load them here. So they will be listed here, and from that point on, then you will be able to perform your functional hazard analysis, right? And in the functional hazard analysis, which is what we're seeing here, then you see basically here the function that we just have, a couple of IDs that can be generated or or can be typed by the user, and finally you see here on the right side these guide words from the HACCP, right? Which you can, let's say, permutate against your functions, and then finally describe the malfunctions, the failure effect, and what would be the yeah, whether it will be safety critical or not for your system. And basically, this can be done by permutating. So you can, as I pointed out, you can define whether you would like to permutate something or not. On the one hand, on the other hand, you will be able to create that catalog of those hazard words. So if you want to add new words or delete the ones that are or removed permanently, the ones listed, then you can tailor it to your needs, right? Okay, and once you do this permutation, basically this occurs automatically. Well, these parts still need to be filled by you with some meaningful explanations. This is where the analysis comes from. And finally, you will be able on the right side to define the hazards, right? And the hazards, as listed here, yeah, basically they need to be crossed against one or the other malfunction. So you have the possibility to define whether um, one of these malfunctions is not really applicable, it cannot be described, or it was described through older failure mode already, whether it is safety relevant or not, and if it's safety relevant, then it will have a cross, let's say, with the hazard that you may have defined, right? This creates, as you see, a traceability already between hazards and functions, right? Good. Once you have done this, then you will be able to perform or create and define the hazardous events. What are the hazardous events? Well, basically, you want to do is take a look at your catalog of driving situations and standing situations, which is what you see here on top. And then basically you can select one of those different scenarios, and by taking some of them of the different categories, of course, as I pointed out, you can't again configure such a catalog. You can define the categories, you can define um, the items in this category, and then you can determine what is the exposure parameter of these situations, right? Good. And by combining those situations, then basically you fill automatically the situation description. Of course, sometimes you may also want to provide some extra descriptions, and then you can do it in this field here. And in the end, you might also describe the accident that may happen from this concrete situation, and therefore, in the end, provide a parameter, a refinement of your parameter, whether it will stick to the ones automatically associated with the situations, or maybe with another. Maybe you want to lower it because you want have an argument for that. So setting situations work similarly, and finally for the risk assessment, well, basically you have a lot of information which is already loaded from existing from the hazardous events, and what you basically have to do here is to fill the part of the severity and the controllability. And if you want, so you can provide, of course, an argument to why is this value coming from, and finally, of course, decide whether what safety goals need to be associated with those evaluations, or this assessment of the hazardous events. Finally, of course, you can also link here assumptions to your safety goals, or let's say to your entry of the risk assessment table, and let's say complete the risk assessment in total. So one of the important things about this tabularized approach, as we have presented here, is that we have here, first of all, a tabularized approach. So this might be confusing for some people, because some people think, okay, if it's small base, it needs to be somehow in a diagram, but this is not necessarily true. So what we have here is simply a tabularized approach, and from which some of these elements are actually modeling elements. So whenever we look here back in the details of our project browser in Enterprise Architect, so we will be able to see that we have here the functions that we use at the beginning, that we have here several assumptions, then we have safety goals, and then we have hazards. So these are basically the modeling elements that we consider most important to be consumed outside of this table. And yeah, of course, the advantage of having this HARA in a tabularized way and not in a diagram is, of course, the compact way it is displayed here. So basically, we don't need to waste a lot of or huge diagrams trying to depict this, because all this information is simply very compacted. Is compacted here, and then we just focus on only the artifacts that are really relevant for the rest of our safety life cycle. And so we will see later how, for example, those safety goals are related to our safety concept, or how can they be linked to or for example, how hazards can be linked to the fault tree analysis, for instance, right? So yeah, I think this gives you an overview of the HARA, and yeah, I would like to then move forward with the rest of the presentation. Good. So coming back to our slides, yeah. So basically, we can move forward with our architecture design part. So and what we mean here, of course, with architecture is there are many things that you can do in architecture, but we want to focus especially on the use of functional networks. So well, this does not really make part of the safety life cycle, Functional networks are really maybe, I would say, it's probably one of the most important artifacts used by engineers to communicate a design, right? And yeah, currently UML and SysML provide support for it. So basically, why do we have an extra implementation in safeTbox? Is the question here, right? So well, first you have a simplified and generic approach here that will allows you to depict your desired level of detail. Well, whether you build a more functional, logical, or technical architecture is on your decision. Let's say in the way you name things, and in this sense, it's also kind of similar to SysML. But of course, with the difference that you don't have so much of modeling complexity as provided by SysML, which provide like many ways of depicting a port, for example, right? So second, it focuses in the interaction with the safety engineers. So we'll see that it will be possible to define, for instance, ASA levels for components or ports, which might represent CAN signals if you want to go for like more technical views, or it might just simply represent a data flow just for data exchange, for example. So it's really up to you how you handle that abstraction level, right? Moreover, we will see that you will have the possibility to associate fault trees to those components and to associate failure modes to those ports. And this is very nice because then we'll see again when we think about our ontology how the artifacts of these different, let's say, main documents belong to each other, or let's say associate to each other. Good. Another point is that you can modularize and instantiate the components, and of course this will allow you to handle the modeling and the structuration of complex systems by creating appropriate hierarchy levels. So yeah, we will also see that you will have the possibility to type your components and type your ports to provide a little bit more of, let's say, further semantics to your roles if this is desired. And yeah, finally we might also take a look at one of the special concepts that we use in safeTbox, which are the realization views. All right, so let's take a look at that in the tool. So yeah, I have prepared for you a couple of examples in this sense, very simple examples for you to follow. So in this first example, I would like to, let's say, want to show you our instantiation concept, right? So in this case, we see here a vehicle, for example. We see the body control module in a vehicle controlling the activation of the lamps, for example, the headlamps, right? So, and how do you model multiple headlamps? Well, we basically support the user in that we have this instantiation mechanism that allows you to find your components easily. So, for example, you have your headlamp, and you want to say, okay, I want a headlamp. I already have my left headlamp. I would like to add the right one, and this will then automatically bring my right headlamp into my diagram, and finally I will be able to connect those signals. And yeah, so you see right now we have, let's say, reuse a component. So whenever we look behind these and we find the realization of this headlamp component, then we'll see that this basically exists only once. Yeah, as you see here in the project browser, we basically have only one headlamp, which has been instantiated 2 times here, on the left and on the right. And this simplifies the way of reusing components in safeTbox compared to what you can do in UML or SysML. Well, basically you have to do a little thing, go a little bit more manual during the modeling phase, and yeah, we simplified this process. so that it gets faster. So as I pointed out, what you could also do here is, for instance, you can define the type of your components. Yeah, you might want to say, okay, this is not a component instance, which is the generic option, but you may say, okay, this is actually a logical component, right? So you might define, of course, your own types of components. This is you will be able to do so through their settings. So you can define new types for components, as well as for flow types. Meaning you may decide, for example, for CAN flow, you might go a little bit more technical for a CAN signal or whatever, and this will you be using basically for your ports. So for instance here, this flow type is none, but you will be able to say, okay, this is a CAN signal, and basically this is now already set for your port, and this will have a couple of advantages. We will see that later when we integrate this with the component flow trees. And yeah, as I pointed out, this will help you, this will allow you to formalize a little bit better your molds. Yeah. So I would like now to explain maybe our second example with respect to realization views, and then what is a realization view. So basically we see that here a component basically is always typically divided into a specification view and a realization view. So the specification view basically hides all the details of the implementation of a component. In this case, this component instance will represent the specification view of the toward controller component, right? While the microcontroller, we are seeing then the realization view of that component. So we're seeing how this microcontroller is being refined internally and what components make part of it, right? And basically, what can you do with that? So as pointed out in the slides, so you can manage, for example, variants of this microcontroller. So you see in our project browser, we only have one microcontroller and we have two diagrams associated to it. Those diagrams, one we have called unsafe, basically has a simplified version of the microcontroller's realization, while the other one has an extra possibility check. And this is what we want to achieve with that. So basically we just don't want to create another microcontroller. We just want to say, yeah, it will be the same microcontroller, but I will have it in two different variants, two different implementations, right? Because we have two different versions of my vehicle or of my functions, and therefore the main interfaces on the, let's say, the microcontroller might not change internally. It might change the functionality, right? That realizes that controller, and this is why the realizations views might be useful for. And what can you do with those realization views? Well, we support you and automate many things for you with respect to the creation, the cloning, setting those realization views for those components and so on. This facilitates a lot the navigation and keeping them all up to date, right? So here you will see, for example, at the top level of the eDrive system, where this microcontroller has been instantiated again, a similar story. So here we see the unsafe version with the microcontroller. Of course, behind this microcontroller is a simplified version, right? And on the other hand, let's say more robust eDrive system, also already including an emergency shut off and more unsafer, let's say, microcontroller, right? And again, here you will navigate to your specific version of the matching, let's say, realization of the microcontroller, right? So I just wanted you to know that is, of course, this can be applied over all the hierarchy, and this will allow you to depict those variants along the whole hierarchy, right? What I wanted also to say about this example was the possibility to or the focus that we place on interaction with the safety engineers. And as you see here, when the actual functional network would not, in theory, have something specific about safety, well, we have considered that, for example, adding the ASIL levels to the components or the ASIL level to the ports of the signals. As you can see here, for example, I may want to decide what ASIL level that signal is, might be relevant to facilitate that communication and interaction between the engineers, right? And another aspect that it is important about this diagram, I hope you will notice, I will zoom up, here is this icon here. This icon here on top means that this component is associated with a failure model. So this is, I would like to bring you there now. And this failure model is basically a component flow tree, right? And this is what I would like to talk about now. So I'll be back now into my slides. And basically this is what we have with what we just saw. A component fault tree, and basically maybe some of you don't know what component fault trees are, but there is, it's not rocket science. So basically component fault trees is the evolution of fault trees, and component fault trees have basically extended the modeling capabilities of a fault tree with extra elements that allows to modularize and to instantiate fault trees into fault trees. And basically this has been achieved through these triangles, yellow triangles here, as you will see in the bottom. This is what we call input failure modes, and also through this instantiation mechanism called CFT instance. And this works very similar to how it works for components. Basically, you can create the hierarchy, you can link, let's say, ports with ports, and this basically can be understood as the propagation of failures within a fault tree of one component to the fault tree of another component, and basically in this way create the failure logic structure for the whole system, also following the same modularization concept as provided by the architecture, right? So this is basically what you can achieve here, and this is basically from the modeling perspective. As again, we will have the same chances for reuse and variability handling as showed before. I would like to show you right now maybe the possibilities that we also have when looking, for example, here at the driver controller, that we basically associate. While we are associating the CFT, the driver control CFT, with the component, we are also able to associate the failure modes with the ports. And this will be very important from the analysis perspective to make sure that the analysis is complete. So in the end, you will have to prove, maybe as a safety engineer, that you have covered all the ports and that you have analyzed them completely. And one way of doing that is through these traces. This makes explicit what has been considered and what not. Another aspect of these is that you will be able to define, for instance, your specific failure mode types for your signals. Meaning, for example, this port here is associated to certain, this failure mode is associated to a port. This port has a special flow type. And then you can define for those kind of flow types the kind of failure modes that these failure modes can have. And this means in the end that you are formalizing your model. And this might help you, of course, depending on how structured you are, moving faster with your analysis, and let's say in a more systematic way. And here you also have the possibilities to create realization views, meaning in the end you have the possibility to to match realization views of your components with the realization views of your components, and therefore keep them consistent with respect to ports, for example, right? And this will be a big gain in this regard. All right. So yeah, this is with respect to the modeling aspects, right? And we going back to our slides. So basically, I just want to finish this part saying that yeah, we also support to a certain extent SysML, in the sense that we are able to integrate fault trees and SysML plus in a similar way as we do it for components, right? And yeah, basically those mappings can be established, the traces can be followed, and so on. It does not have that power of, let's say, the type mechanisms, because, well, yeah, this is very safeTbox specific, and yeah, will be hard to support with XML, but of course, since the tool is extensible, you can implement it yourself, or we can implement it for you if desired. Right. So, as I pointed out, we have a strong focus on safety analysis, specifically in fault tree analysis. So our tool not only supports the modeling aspects, but also the qualitative and quantitative analysis. So on the qualitative area, we support the minimal costs analysis, and on the quantitative area, we support the top event probability, the event importance, and the common cause failure analysis. So you will be able to decide here in the end whether you would like the tool to be to perform the analysis on the IESE computation backend, or you will be able to do this with isograph fault tree plus. So there is a possibility to connect the tools. So and how this actually works. So yeah, when we look back, let's say for example one of the fault trees, then we'll say for example a basic event can be here parameterized. Like for example, you can choose between a fixed probability, you can choose rate, dormant, time at risk, or uniform. So we have not supported yet in our computation backend all the let's say distributions that fault tree plus support, but let's say we have chosen the most common ones. And yeah, you will be able to, let's say, parameterize basic events and parameterize input failure modes. And why is this the case? Because, well, basically what you can do is to let's say assume to a certain extent what will be the failure probability coming from another component. Let's say if you are depending on the input of other components, then you might assume, let's say during your development, what information this will be if you don't, let's say, receive the fault tree and you cannot integrate it into your own fault tree, then at least you might receive this information and then you might model it here internally, and therefore perform modularly the analysis, let's say on any level. So you can here on the bottom, or you can do it also on the very topmost level, let's say on your top events, but you can also perform it on any intermediate step, and this will consider the from that point on to the bottom of the tree, and will calculate the metrics for you, right? And how that looks like, so we may have seen already a short got an idea of how that looks like. And here you see, for example, yeah, those probabilities, those cuts. You have here the details, and you of course you will be able to navigate through to those basic events or input events, and yeah, in the end you will be able to export those results to Excel, or you will be able to create a results artifact, which is basically what we have here, which means has been a modeling element has been created and can be used, let's say, for instance, as a as an evidence within your safety case or your safety concept, right? Which is, yeah, where we're going next. So yeah, within the safety box, we have implemented the goal structuring notation, and we use this basically for two purposes. So basically, you can create your safety concepts, and you can create your safety cases with that. Yeah, what is ESN? ESN is basically a modeling technique to organize and to create arguments, to structure arguments, right? And this is basically what you do, what you want to do with your safety concept, because you want to structure how is actually your system safe. And you really would like to explain this in few sentences, right? And this technique allows you to, let's say, organize the more important things from coming up from, let's say, a safety goal, which might reference a hazard and a HARA, and of course bringing down, split those, let's say, safety goal into functional requirements, going down into technical requirements, and you might go, of course, to, let's say, allocation of components if you talk about the safety concept. And if you go, for example, to the level of solutions, meaning you will use solutions to provide the let's say, the evidence that something has been fully completed. And this is basically that you would use a modeling artifact that you would use most commonly in the safety case, which most probably links to high-level artifacts. Like, for example, you may have an argument that says, yeah, I'm sure that I tackle all my hazards that I have, all hazards that I have identified has been tackled, and therefore you can prove through a validation result or, yeah, through analysis that this has been the case, right? And this is what you would do most of the times with solutions. And how can you do that? Well, basically you do that by referencing those artifacts. So this is, let's say, the nice thing about it. And yeah, basically we would like to see that now, how that looks like. So yeah, let's take a look at our safety documentation. So yeah, basically, as I just pointed out, this safety goal, we have created here a done example for showing one of the safety goals that we have found, let's say, or identified through our hazard analysis. So we'll see, for example, here that in our risk assessment, the safety goal for here exists, right? And whenever I say navigate to safety goal, it will bring me directly here, where I basically have bring it down, or let's say split into functional requirements, for example, right? Moreover, you have the possibility here, so it's a nice thing about the not only the GSM but any other artifacts within safeTbox, is that you are able to link easily to other artifacts within the model. And basically you see here, for example, that this safety goal exists in the contents of the E drive, which you can of course navigate to, and then of course this exists in many different kind of diagrams, then you would like to navigate there. Moreover, you will be able to create a new link, for example, to, let's say, I don't know, whatever, for example, the microcontroller that we have seen in the past, like the component or the CFT, and then you want to explain how things belong together, and you see the traces will be created in the back for you in a very easy way. And it will also tell you, for example, here marked in yellow, whether the links are in a good shape or not. So for example, in this case, it's kind of like a warning, this yellow color, meaning that this link has been broken. You can recognize this in the model. Let's see that a little bit closer. So it's a broken link, and basically this means in this case that you have two kinds of broken links. For instance, the ones that are repairable, in this case this is the one, or the unrepairable ones. The repairable ones are the ones whenever the link is actually missing, and whenever the object is missing, that this will not be repairable anymore because you cannot reconstruct those elements, right? But this at least will warn you, hey, you're missing something here. We can guide you through that process, right? Good. Another aspect that is interesting also from the IESE point of view is the possibilities that you have to reuse other artifacts, or let's say reuse of already existing functional requirements for other kinds of arguments, or let's say to modularize your concept. So for instance, you may say you may want to create another argumentation module, and within that argumentation module, let's say you want to create a model reference, right, which you, let's say, make a reference to from a strategy, and that makes part um, of your concept, right? So something like this, and basically this would explain further how things belong together. And so this is allows you, similarly as the other techniques, to work in a modularized way. And this is kind of like one important aspect of whenever you want to, let's say, reuse, and you want to yeah, basically modularize and keep your system to components, and you want to, let's say, avoid the complexity of mixing everything. And this is one of like the big advantages of having a model-based approach. Basically, you have all the elements within in the back, and then you have many views that show up these elements in a slightly different way, or connected in a different manner. And basically what you're winning with that is that yeah, you basically again focus your the information for one specific stakeholder. So what we have seen here most of the times is, of course, in the focus of the safety engineer, which is our target. But again, this information is in such a readable way that maybe some other people outside the safety domain would be able to follow them and to read them. And yeah, so we see here an advantage in this regard. All right. So yeah. Yeah, as you may have noticed, so we basically do not cover the entire safety life cycle, so we are not there yet. And but we want to mention basically what are the things that we are working on. So basically, we're still working on the requirements documentation. So we see that there is a potential there for, of course, achieving those traces between the requirements and the safety concept, and to document this in a more proper way than just having an extra tool for that. Yeah. FMEA, of course, is a very common analysis technique that a lot of companies use. We have always preferred the fault tree analysis because the modeling power is much higher. But let's say the FMEA has certain advantages with respect to fault identification, and this is why we are working on implementation of it, trying to integrate it into our modeling concept, and yeah, this will happen in the coming releases. Yeah. Yeah, integration of security aspects is also something going on. So basically, yeah, we are researching in this area. Security for safety has become in last years quite important because of the openness of the systems, and the integration, or the need for integration, and therefore we see here high potential, and we're working on that too. Um, Also, simulation is also a big topic for us, basically because of these big challenges in the um, artificial intelligence. We basically want to, let's say, get a little bit stronger. So we have in the institute also some simulation tool the Feral tool, and we basically want to connect this tool and to connect to other vendors like Simulink and so on to, let's say, all the concepts that we have in the back with respect to fault analysis during runtime, be able to connect those together and trying to bring things more from the design to the runtime in the future. Yeah. So yeah, this is pretty much the presentation. So it was a lot. I hope you got some of the ideas of safeTbox and why having a model-based solution is important, and what are the gains from it. And yeah, if you're interested in trying safeTbox, then you can download it from the safeTbox website directly. So you just need to register, and after registration, the download is free. So yeah, you can also visit our blog for the last news about the tool, and you can also, of course, contact us directly whenever you have questions. And yeah, if you are also interested in our document and samples, then you will find some information about like the user manual and a couple of examples as I presented today, so that you can follow a little bit better how safeTbox work. Yeah, so I think that's it from my side. So basically, yeah, you can contact me again. Here is my telephone number and my email account, or you can of course send us an email through the safeTbox email, and yeah, we will be willing to answer your questions. I think luckily we don't have so much time today, so I think if you post your questions on the comments section, I will try to answer them as soon as possible and of the best of my knowledge. So yeah, thank you very much for today for assisting, and yeah, hopefully see you in next time. So that's it for today. Bye bye.